right, let's recap. If you need this, if not, you can go to the next playlist. But we're going to look at angle measurements. Normally, an angle measure, we look at it in degrees. Okay, so an angle is two rays that meet at a common, and I should do it here, at a common vertex. So now we're going to measure that angle instead of in degrees in radians. Now, a radian is very special because it matches, we have parts that have a relationship for it to be a radian. So a couple things. Your initial side, this is like the starting point or the start side to create the angle. So this is the first ray, and then it opens up. Terminal is where it stops at. Okay, that's where it ends. And so we're going to create a radian using the radius. And so I'm going to show an animation to kind of help you see this. Let's go right here, sorry. So on here, the radius is the red lines. If I use the length of that radius to match the length of the arc that is created from that central angle of those radius, then that would be a radian. Okay? So the angle that we have here matches the length, oops, it won't pause for me, sorry, of our radius. Now, so the arc length, that's the blue line here, that length is the same length as the radius. Now, if I continue to look at, and I just kind of move that arc length and create another central angle, because it's going to be the same as the radius, that's now 2 radians, okay? And I could move it again, make another one, and if you look, I can get 3 pieces, 3 radians in half a circle, but I got a little piece left over, okay? Got a little piece that's left over. So if I know that the whole circle, half a circle is 180, then each piece has to be, because if I do 180 divided by 3, that's 60. It has to be less than 60, because we have this little piece that's left over, okay? So a radian is just a special situation, a way of measuring angles on a circle so that your arc length, and that's here, that was our S, equals the radius, which was the red line, okay? And that's what they were showing on that. Now, to go from radians to degrees, okay, there is a rule you have to follow. One, remember that radians is always in terms of pi, so you see a pi in your measurement. We're going to, this arrow saying I'm going from pi to degrees, and you're familiar with that. So to do that, you're just going to multiply, and you're going to multiply by 180 over pi. 180 over pi. Sorry about that. So when I'm going to radians to degrees, I just multiply by 180 over pi. So here's an example. Add this to your notes if you did not get this. If I have 3/4 pi radians, and I want to convert to degrees, first I got to just identify what part is the radians. Well, the radians is the 3/4 pi, because it has a pi. So to change that to degrees, I take that 3/4 pi, and now I multiply it by 180 over pi. When I do that, the pi's actually cancel out. So what you're left with is 3/4 times 180. Or you can say, I'm going to do 3 times 180, then divide by 4. You can do different ways. We want to simplify and get an angle measurement for that. And when you put that in your calculator, you end up getting 135. So we get 135 degrees. Okay? So that is converting from radians to degrees. You multiply by 180 over pi. Now if I'm going to degrees to radians, got to go reverse order. Degrees, remember, again, we have a degree symbol. We're going to radians, so we want a pi in our answer. Well, here we just now, since we're doing the opposite, going in the opposite direction, we got to do the reciprocal. So we just multiply, I'm just going to abbreviate multiply. We're now going to multiply by pi over 180. Before we had 180 over pi, now we're going to do pi over 180. So for example, let's say you have 100, we want to convert 120 degrees to radians. So to do that, I need to know my radians. I need to know my degrees first. What's the degrees? The 120. So I take that 120, multiply it by pi over 180. Well, that's like saying 120 over 1, but really what happens is I take that 120, put it over 180, and then I'm going to add my pi to my fraction. So I can go to my calculator. The beauty of our calculators that we work with, we take that 120 divided by 180. Oops. Hit enter. It simplifies it for us. So that is our answer. Whatever we get simplified in the calculator, that's what we're going to use. So we're going to have 2/3. So this equals 2/3 pi radians. That's just abbreviate for radians. Radians are rad. Okay? So that's our rule. Now we had some practice problems, and I want you to make sure you get these problems. We went over them, but let's make sure we have them. And there's the key. I'm going to have all of them. Some people had them finished, some people didn't. And then we had an actual homework assignment over converting from radians to degrees and degrees to radians. So here we want to convert the degree to the radian. It says pi as a symbol and a fraction. So just take it. We're going to take that, because we're doing pi over 180. We're multiplying just by pi over 180, which really is just taking that angle, putting over 180, put pi in my answer. So we just need to simplify that. And this comes out to be 736 pi. And we're just going to box that. So same thing, we're multiplying by pi over 180. This ends up being 160 over 180 pi. We simplify that, 8/7 pi. Okay, it's radians. As long as we have pi in our answer, we're good. Don't let the negative fool you. We're multiplying again by pi over 180. We get a negative 15 over 180. Put our pi, 112 pi. So what I ask is for you to finish this section and to get the answers. If you want to pause the video, pause it, check it, then make sure you have it done, check it. But if those of you did, because many of you were ahead, you should have 7/3 pi for 4, 117 over 90 pi, and a negative 1/18 pi. So that was that section. The next section, we're now converting from radians to degrees. So to go from radians to degrees, we now multiply by 180 over pi, because we want the pi's to cancel out. This is really saying 180 divided by 8, because what's on top stays on top, what's on bottom stays on bottom. And this comes out to be 45 over 2 degrees, or you can change that to a decimal, 22.5 degrees. So again, when you have the pi, you have the radians. To get rid of the radians, change it to degrees, multiply by 180 over pi. Your pi's cancel out. Really, what's going to be on top is 7 times 180 divided by the 16. This can reduce to 315 over 4, or 78.75 degrees. These are degrees. So same here. We have 11 pi ninths. So we multiply by 180 over pi. The pi's cancel out. You can say 11 ninths times 180. Just take the fraction that remains times the 180. Or you can say 11 times 180, then divide by 9. And then that gives me 220 degrees. So go ahead and pause the video, check your work for this section, and then if you're ready, go ahead and just fast forward to the homework help.